This is Project 11 of Hacking with Swift. We're going to make a game using Sprite Kit, Apple's high-performance 2D games framework for iOS. For more information, see the website hackingwithswift.com, where you can buy this video in high resolution or buy it as an ebook for just $3, or buy the whole series as an ebook. The books contain lots more information, really guiding you through every step of what the code does. Alternatively, you can follow me on Twitter. I am at 2straws. If I have time, I will help you with problems with this code and the project. Get in touch. Okay, this code is going to feel like a real start from scratch for you, because everything so far has been using UIKit, Apple's user interface design framework. And now we're switching to SpriteKit. In fact, every game from now on will use SpriteKit, which is Apple's extremely awesome toolkit for designing 2D games. So it's going back to basics, sorry for that, and it does mean this is going to be a fairly long tutorial, so sorry for that too. I'm sure you're very busy and want to do other things. But it's going to be a really cool project, and you're going to love making it because SpriteKit really is extremely powerful. So go ahead and launch Xcode. Choose Create a new Xcode project and choose iOS Application Game. Then click Next. For the name, I'll call it Project 11. Make sure SpriteKit is selected and then iPad for device. Do not choose SceneKit, choose SpriteKit. Then click Next. Save to desktop wherever you feel like it. And for your target, this is important, do not choose iPad Air. Choose iPad 2. iPad Air and iPad Retina are both Retina-sized iPads. They have far more pixels to draw. And SpriteKit games are quite intensive, so they will run much slower in a Retina simulator. They run really fast on a real Retina device, but in a simulator, always choose iPad 2 when working with SpriteKit games. So choose iPad 2, then press play, and you will see the default built-in template. It'll build and run. There we go. I'll switch to landscape, hello world in the middle, and when I tap, you get a sort of spinning spaceship. Like that. Yeah, spin and spin and spin and spin and spin. So that is the built-in code Xcode gives you to get started. If you look in the bottom right corner down here, you'll see it has 16 nodes. That's sort of the number of things visible on the screen. This is a node. Each of these spaceships are nodes. And then 57 right now, 58 FPS, that's frames per second, how fast it can draw the screen. And you want to get, ideally, 60 FPS all the time. So let's stop this project. And we're going to go ahead and remove things to get it up to where it needs to be. So choose images.exe assets, select the spaceship, and press the minus button to delete it. Now go to gamescene.swift. Ignore game view controller. Go to gamescene.swift. You'll see did move to view. Select all the code in that and delete it, leaving the method itself intact. The same for touches began. And boom, that gives us a nice clean skeleton project we can build upon. Now, you should already have the source files for this project. Here they are on my desktop here, Project 11 files. Inside there is a folder called Content, and inside there is a load of stuff. Please copy the entire content folder into your project. Just drag it in to supporting files, make sure copy if needed is chosen, create groups, and press finish. So let's kick this off by removing that gray background. You'll see it's a large grey thing we saw in the design, and that's controlled by our scene here. So in did move to view, we're going to add a background image that's inside the content folder you just copied in. It's a file called background.jpg, and we're going to position it at the center of the screen. Now, unlike UIKit, this is important, unlike UIKit, SpriteKit works with the center of objects. That is, 0.00 is the horizontal and vertical center of a node. In UIKit, 00 would mean top left corner. Also, unlike UIKit, SpriteKit's y-axis starts at the bottom and works its way up. So Y0 is down here, and Y768 at the top. So it inverts the Y-axis. So to place the background image in the center of a landscape iPad, we need to place it at X512, Y384. And we're going to do two more things while we're here, both of which are only needed for this background. First, we'll give it a special blend mode called Replace, which affects the way it's drawn. And Replace means just plaster it on there. Don't think about alpha channels for opacity. Just draw it on there and ignore alpha entirely. Secondly, we'll give it a Z position of -1. Z position is ordering inside the scene. Higher number Z position means closer to the screen, closer to you, sorry, meaning that it's higher up in the game so it can be seen. And -Z means go behind things, so it affects the stacking of nodes. Let's do the actual code for this so it's clear to you. First, we create a new constant called background. And this is a new data type called SK Sprite node, like that. This has an image named initializer, and we can just specify background.jpg, like that, inside image named. We position it, like I said, at as a point using a CG point struct, which takes an X and Y coordinate. So we'll say X is 512, Y is 384. That's just a point, a coordinate on the space. We'll give it that blend mode of replace, which affects the way it's drawn, equals .replace. It will look the same because our picture is indeed opaque. There are no transparencies in it at all, but it will draw faster. It's a more efficient way of drawing stuff in SpriteKit. And we'll say background.z position equals -1. Go to the very back of our scene, so everything else appears over the background. Finally, we need to say add child to the background, which means add the background to the scene, because we are a scene. Press run now, and you should see the background in the game. There we go, a sort of a metallic blue background color. Now, it's hardly a massive improvement, but it's just the beginning. So we're going to add to this boxes that are made when you touch the screen. So inside touches began, we have to use a method called location in node to find out where a touch was. Because we get given in here a set, an NS set called touches. NS set is just like an array, except items can appear only once. It's like a unique array. So we're going to say, hey, touches set, give us any of your touches. We don't care which one. We don't care at multi-touch. Find out where that touch was in our node. Then make a box there. So to do that, we first say, give me an object. So we say if let touch equals touches dot any object, and then cast it as conditionally UI touch. So we'll get a load of touches here. We're not sure how many actually there could be like 3 fingers down at once perhaps. We say give us any of those things. Make sure it's a UI touch. That's the class Apple uses to represent touches to a screen. And then we optionally unwrap it because it might be nothing. We're not sure. We're not sure what value will come back. And if there is a touch and it is a UI touch and we can start using it, it'll go into this constant here called touch. We then say let location equals touch.location in node self. That will say where in my scene did the user tap. And we can then act upon that. So we'll say now let box equals sk sprite node. And there are several ways of creating sprites. We just used image name to load the background. There's also color size. Color size generates a sprite box just for us, easy to debug with. We can say I want this thing to be UI color dot red color. Give me a red box at size. This is just like CG point. It's a structure that holds a width and a height. It's a very simple little data holder. So we'll say CG size. CG size, a capital S. With width, we'll do 64. Height 64. Then end the parentheses like that. So that creates the box. We want to position it. Box.position at the location where we touch the screen. So equals location, and then add that box to the scene, like that. If you press play now, what will happen is we have the background picture as before, but as you touch, it draws boxes onto the screen like that. Hardly exciting, but also not very hard so far. So that finds out where these are touched and adds boxes there. It's hardly exciting. So we're going to make this box more interesting. We're going to tell the box to behave as if it has physics attached to it. So after creating, we'll say box.physicsBody equals skPhysicsBody, parenthesis, rectangle of size. Now we know the size of our rectangle because we just used it already. It's CG size, width 64, height 64. So we know the size of the rectangle. And when you do that, it now makes the box act like it has physics. We can press run again now, and what will happen is when we tap to create squares, they fall off the screen because they're immediately being affected by gravity. But it's still not really much of a use to us because they just fall off the screen. What we can do is, in did move to view, we can give our scene a physics body too. We can say physics body equals skPhysicsBody, then use edge loop from rect. An edge loop goes all the way around something like a containing box, which is exactly what we want. We'll say edge loop from rect, then do frame. So our frame, like that. So what will happen is the boxes now have a rectangle physics body, and our scene now has a edge loop physics body, which should contain the boxes inside it. So we press run now. You should see, tap to create a box, it falls and bounces off the bottom perfectly. And we can start stacking things up. You see they fall around, bounce beautifully realistically. Let's create a little tower. Maybe tip it off to one side. Ah, fantastic, look at that. That is all the code it takes. It's crazy. SpriteKit is just so powerful and just so fast. There really is nothing holding you back. And we're just getting warmed up here. So that's how we're going to create boxes. But no one will get rich on the App Store by creating red boxes on the screen. Instead, we want to use pictures. So what we're going to do is we're going to take this code here out. Let's keep let location because that's helpful. And instead, we'll create a ball. So we'll say let ball equals skSpriteNode. Again, using image named. And we'll use ball red. You'll see in the content folder, there's ball blue, cyan, green, grey, purple, and red, and yellow for you to use. Whatever makes you happy, pick a color from those that you like. That will load one of the ball pictures into our ball constant. We then give the ball a physics body, and this time, rather than rectangular size or edge loop from rect, we're going to say circle of radius, because you can give things circle physics as well. So we're going to say it should be ball.size.width divided by 2. If you know diameter and radius from school, that's why it's like that. 2.0 really, but all the same. Then we'll say ball.physicsBody. Now this is optional, so you should really unwrap it, but we know it exists, so we'll just force unwrap it. Dot restitution, which means bounciness. Ball bounciness equals 0.4, 40%. It's 0.4 means 40%. Then position it where we tapped, so ball.position equals location, and then add child, ball. Boom. Now we have a ball physics bouncing around, and we can drop balls in our scene. Like that. Fantastic. So they roll around now. It's a lovely bit of code. Very, very nice. Look at that. Fantastic. If you want, you can increase the restitution up to, say, 1.0 to get crazy bouncy balls. That's 100% bounciness now. So you get these huge bouncing balls almost back up to where they were. It takes a long time for them to come back again. And you can create some obviously crazy scenes as they all bounce around like sort of particles that are being heated up. Like that. Oh, fantastic. Physics is just so much fun. You feel like you're doing all this great work, and actually the physics engine's doing most of it. Other end of the scale, of course, is like 0.1, barely bouncy. This thing is made of lead ball like this. Donk. Don't do that. That's quite boring. Let's go back to 0.4. Good number to choose. So you can now tap on the scene to drop bouncy balls. It's fractionally more interesting, but still, let's face it, a dreadful game. We're going to fix this by adding things for the balls to bounce off. So in the content folder I gave you in the project files, you'll see a thing called bouncer. It looks like this rainbow circle thing. We're going to place those in the game now so the balls can bounce off it. So just before the end of did move to view here, add this code. So we'll do let bouncer equals sk sprite node image named bouncer. For ping files, PNGs, you don't have to specify an extension, so we don't have to write bouncer.ping. It assumes ping. For JPEGs, you do have to specify JPEG. So let bouncer equals sprite node image named bouncer. Then we'll position it on the screen. So we'll do bouncer.position equals cg point. And the pointer is x512 y0. Now remember, SpriteKit works with centers of stuff. This will center it at the center of the screen, just at the bottom of the screen here, because it's centered on that position. Then we'll give it a physics body, so we'll say bouncer.physicsBody equals sk physics body, circle of radius because it's circular, and the radius should be bouncer.size.width divided by 2.0. We're also going to add a new line for the physics body, which is this: bouncer.physicsBody force unwrap dynamic equals false. Dynamic means should the physics engine be able to move this as a result of forces. False means no, don't let it ever get moved when things hit it. And now if we do add child bouncer, here's what you'll see. So the iPad landscape screen is 1024 across, and we said 512, and it works in the center of the bouncer. So the center of bouncer means that's at 512, and it's 0y, so y is 0 at the bottom here. So it puts it halfway off screen like that, rather than fully on screen. If we drop a ball now, you'll see it bounces off it like that. So it kind of rolls down this little rainbow thing, which is pretty cool. So we're using CG points, we're using CG size, we're using physics body already. We're coming along quickly here. You'll see CG point quite a lot, by the way. It's a very common way of specifying points, x, y coordinates, and same for CG size, we're doing sizes. So using this code, the bouncer node is placed on the screen and the balls can collide with it, but it won't move. If you had taken out the dynamic thing, the bouncer would move, which just looks wrong. You'll see it's on the screen fully because it's hit the edge, wrecked, and we can drop balls into it and make them collide and literally push the bouncer along, which is just weird, right? That's not the job of it in this game. So take it out again, make it dynamic false so it works correctly. So what we want to do now is have multiple bouncers on the screen, and you can, if you choose to, think, well, we're going to have, say, 5 bouncers. Let's copy and paste that code 5 times, like this. Don't do that. That's obviously very bad, because if we change the code later on to say bouncer's different picture, or bouncer is dynamic, who knows what, or bouncer has different physics, we have to change it 5 times, which is very frustrating. So instead, we're going to make a method that does all the work for us, and then call that method every time we want a bouncer to be made. So the method code is basically the same as what we have so far. So we can literally copy and paste this text out and make a new method called func make bouncer at, and it takes a position, which is a CG point. Then paste that code in there. Change the position line to be position, and that's the code. That's it. So that's our make bouncer at method, and we can use that 5 times to show it working correctly. So we'll say after physics body, we'll say make bouncer at CG point x. We'll do 0 0 first, then copy and paste 5 times like that. So 0 0. Then 2560, then 5120, 7680, and 10240. So evenly space them across the screen, each time calling this method. Go ahead and press play. Boom. 5 bouncers now on the screen, which will bounce things around into the gaps in the middle. One thing to say, we have not locked the screen orientation, so you can rotate it, which will cause all sorts of problems. I do suggest with games you do lock the orientation. So go to the project editor and choose landscape right, left or right only, so you can't rotate it anymore. So we get in there now. We've got something there that the balls can bounce off to make the game. The next thing is to make the bits between the bouncers down here, the slots, the thing the balls ought to hit in order to win the game. And we're going to fill the gaps with two types of slots. Good slots coloured green and bad slots coloured red. That's how people score or lose points. As with bouncers, we need to make a few of these, specifically 1, 2, 3, 4. So we'll make a method again. We'll call it make slot at. So func make slot at. Again, it needs a position, CG point, but this time it will also accept is good as a bool. Is this a good slot or a bad slot? And it will affect the way it's drawn. So we'll say var slot base is an SK sprite node, and then say if we are making a good slot, then slot base equals SK sprite node, image named, and I've called my things slot base good. So slot base good. Like that. Else, if it's bad, we're going to call it slot base, surprisingly enough, bad. So we reuse this variable twice. It's set either here or here, but it's always set to one of these two things. And then, no matter whether it's good or bad, the same code runs, slot base dot position equals position, and then add child slot base. So the second parameter affects whether we load the good slot or the bad slot. We then have to call it 4 times in here. You can do it before or after. I think before probably looks better at the end of the day. You'll see why later. So just before make bouncer, you want to say make slot at CG point, and then X should be 1280 is good. We'll make that one good. Copy and paste that 3 more times. So X128 is the first one. Then we'll have 384. Then we'll have 640, and then 896. So it's evenly spaced again. And we'll make the first one good, second one bad, third one good, fourth one bad. Press play now, see how that looks. Fantastic. So bouncer, 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 red slot, green slot, red slot, green slot. So it's kind of coming together a little bit. Now, obviously, the nice thing about this is that we're using methods for these, the creation of these nodes, which means we can change the method, and all 4 of those will change because they're all calling the same method. For example, we're going to add a glow to our slots to make it a bit clearer which one's good and which one's bad, because it's not very clear right now. So we'll have another thing in here. We'll say var slot glow is also an SK sprite node. Then if this is a good slot, let's copy and paste this line. We'll say slot glow equals slot glow good. And then copy and paste that again. And slot glow equals slot glow bad. Then give it the same position. So slot glow dot position equals position. Like that. And then add both of them, slot glow and slot base, to the scene. Like that. So it basically doubles every line of code. It has doubled every line of code, just changing base to glow. But the end results are quite pleasing. It's much clearer now which one's a good and bad slot. You can see it's got this glow effect coming out of it. It's cartoony, but it works. We could even make these slots spin around by using a new class called SK Action. Now, SK Actions are extremely powerful ways of making your nodes move and scale and behave in interesting ways in your game. But you do need to learn a few things before you can start using SK Actions. Firstly, any angles, like rotation angles, are specified in radians, not degrees. This might feel a bit like your maths class all over again. This is true in UIKit as well, to be fair. So as a reminder, 360 degrees is how many there are in a circle. That's equal to 2 pi. That is the mathematical value pi times 2 radians. So pi radians is equal to 180 degrees. This is important because you will use radians in your code. Now, rather than have you try and memorize pi, even though it's great fun, there is a built-in value of pi called m_pi. Problem is it's in a data type double rather than what SpriteKit wants, which is called CG float, which is a whole new way of storing exactly the same stuff. Thanks, SpriteKit. Double and float you've seen already. Double is the super precise floating point number, and float is a less precise decimal number. CG float's a cunning way to be both, depending on what kind of device you're running on. So it is subtly different, but it's very, very subtle. When you create an action, it will execute only once. It will just happen straight away and never again. But you can create another action to wrap it called repeat action forever. So anyway, we're going to make our code rotate this glow node by 90 degrees, which is basically half of pi radians, which is available as a constant by itself, by the way, over 10 seconds, then make it repeat forever. So to make that happen, into your code, just for the end of the make slot at method, we're going to say let spin equals sk action dot rotate by angle. It wants a radians in CG float, so we must create a CG float out of m underscore pi. Actually, underscore pi 2 because we want 90 degrees, but it's all the same really. Duration 10 seconds. Then we'll make a spin forever action out of that, which is done by saying sk action dot repeat action forever spin. And finally, slot glow dot run action spin forever. So that will spin it by m pi 2, i.e. 90 degrees, over 10 seconds, again and again and again. So it'll just carry on spinning. Press play now, it should look a lot nicer. Look at that. Absolutely beautiful. So the glow spins around very gently. Simple effect, but it looks good. The next thing we're going to do is look at our physics again, because we want the player to win or lose depending on how many balls they get in the green slots. And you can see right now the ball actually lies just about over the green slots. If you can just about see that on my screen. It's not hitting the green slots at all. And this requires collision detection. Now, obviously, collisions are happening right now because when the ball bounces, it hits a bouncer and spins off. Things are colliding. The problem is we are not being made aware of the collisions, so we can't take action based on it. To fix that, we're going to do 4 things. Firstly, we're going to make our slots have rectangle physics, which you saw in the beginning with the boxes. Second, we're going to name the slots. We know which is which. We'll call the bad ones bad and the good ones good, so we know which slot is good and bad. Secondly, we're going to make our scene the contact delegate of the physics world. And that really means tell us when any contact happens between 2 bodies. And finally, we'll make a method that handles these contacts and does something interesting. So first things first, when we make the slot base thing here, we want to give it physics. So we're going to add the child to the scene and then say slot base dot physics body equals sk physics body rectangle of size, and we want to use slot base dot size. Just use whatever size it is right now. We also want to make it non-dynamic. So slot base dot physics body unwrap dot dynamic equals false. That is, when a ball hits a slot base, the ball should bounce off fine, but the slot base should not move as a result of it. If you play it back now, you should see the ball. It's a very subtle difference, but the ball will rest on top of the base, like that. So rather than sitting in front of it, it rests on top of it, because that's now responding to physics correctly. So that was quite straightforward. The second one is slot naming. This does require a little bit of explanation. It's not hard, but I want to explain how it works. With UIKit, you can just store properties pointing at stuff, so you can reference it later. You can do the same thing in SpriteKit, and you will do a lot of the time. And in UIKit, if you haven't got a property, you can use tags to identify views uniquely. In SpriteKit, there is no tag. Instead, Apple suggests very strongly you should name your nodes and compare their names to see what node is what. This is really easy to do. So back in the code, when we create the slot base for it being good, we're going to just name things. We're going to say, listen, if it's good, then call slot base dot name equals good. That's it. It's just a name, and you can assign anything you like to that that's meaningful to you. It means nothing to SpriteKit. I'll put in bad for the bad one, so we know it's a bad node. It means nothing to SpriteKit. It really does. SpriteKit didn't care less what your things are named. It's for you to say which node is that, which node is that. You can identify them more clearly. Then for balls, when we create the ball under touches began here, we're going to say ball.name equals, unsurprisingly, ball, like that. So we now know the three nodes that matter. We're not naming the bouncers. We don't care about the bouncers because we don't care what collides into them. We just care the fact that the balls and the two base is good and bad both have names. Now comes the tricky part. We need to make our scene the contact delegate of the physics world. Contact delegate means who should be told when two things have collided. In our case, colliding with the slot and the ball will happen. So simply enough, we have to make ourselves conform to the SK physics contact delegate. That bit's easy. Just go to the top, say class game scene, :SK scene, comma, SK physics contact delegate. But you know when you conform to that, you have to implement any methods it requires. There isn't anything really actually required, but we have to add one in a minute. So we'll make ourselves the delegate of the thing. So we'll say our physics world, physics world, not physics body, dot contact delegate equals self. So we are now the contact delegate for the scene. We'll be told when things happen, but only when we request it, which is annoying in some respects, but extremely efficient in other respects. And I'll explain why. Contact, when two nodes collide, when two SpriteKit physics bodies collide, the calculations behind that take time. Your code takes time to run. Calling your method takes time to run, yada, yada, yada. So if you were told by every collision ever, your code wouldn't be very efficient. It would slow down dramatically. So instead, you get to tell SpriteKit, actually, I care about this thing colliding with that thing, and ignore everything else. And it'll only tell you when those kind of collisions happen. Now, we're going to go into much more detail on this later. Don't worry, I'm trying to skip over it now. And we're going to use a ridiculous shortcut that will make some Swift people scream at their screens, I promise you. But we do it much nicer, much cleaner later. This is a lovely shortcut to focus on what matters. We're going to set the contact test bit mask of our ball to be its collision bit mask. Now type the code in, then explain what it does. So just before we set restitution, so just here, please do this. Ball.physicsBody, force unwrap, dot contact test bit mask equals ball.physicsBody unwrap dot collision bit mask. This bears some explanation. There are 3 bit masks you can set. These are identifiers ultimately for a physics body. One is called category bit mask. What type of physics body is this? And you might say it's a ball type, it's a building type, it's a banana type, it's a slot type, who knows what. There's also a collision bit mask. What things should this physically bounce off inside the game? By default, this is set to everything, which is why already our balls bounce off things, because by default, everything bounces off everything else. The contact test bit mask is what collisions do we want to report back to our contact delegate. And by default, that's no collisions. And that's where we have it right now. This means bounce off everything. This means don't bother telling anyone. What we're doing is we're assigning that to mean that. And what happens is it means tell the delegate, us, the contact test delegate, of every collision I collide with. Tell it about everything I collide with. This is clearly inefficient because, if you collide with bouncers, it's not brilliant. You don't want to know about it. But for now, in this particularly simple project, this is a fantastic little shortcut. So this means we want to know about everything the ball collides with realistically. And we're going to do the same thing for the bouncers. So up here in the make bouncer app method, do the same thing. Just copy and paste the line. Just make it say bouncer.physicsBody. So it'll tell us about every collision we have with the bouncers and the balls, which is fantastic. Again, we will do that better later on, but for now it's a perfectly fine shortcut. So before we look at the method that handles contacts, handles actual collisions and does stuff, we want to look at the ultimate goal. What should happen? And what we care about is when the ball collides with a good slot or a bad slot, destroy the ball and do something else. For now, we'll just destroy the ball. So we'll make a new method called func collision between ball, and it takes a parameter called ball, which is an SK node, and an object, which is an SK node. SK node is the superclass of SK sprite node, because there are other kinds of node like labels and shapes and stuff, and they're all types of SK node. That should be a capital N there. That's my mistake. Sorry. So this will be called when the ball collides with something, this object, else. What we're going to do is we're going to say, is that object named good? If so, we'll call a method called destroy ball, passing in the ball. Otherwise, else if, which we haven't done before, otherwise if object.name is bad, then destroy ball. Destroy ball, all it's going to do is say func destroy ball, takes a ball, which is an SK node. All it's going to do is say ball.remove from parent. That means take it out of the game scene. So when the ball collides with anything else, is that other thing called good, i.e. our good slot? Destroy the ball. Is it called bad? Yes, destroy the ball. Either way, destroy the ball. We'll fill that out shortly, but it's enough for a basic example of what the code needs to do. Now, the interesting part, we're going to add the contact method. We will come back to this shortly and add more stuff in here. We're now going to use our contact checking method because it basically writes itself. With these two methods done, the contact method is really, really simple. So, what we're going to do is make a new method called the didBeginContact. It tells us where the contact happened, how strong it was, and what the two bodies were, as well as other stuff. So all we need to do is make this function. It's called func didBeginContact. There it is, code completion. Use that, fill it in. And what we're going to do is we're going to say, did the first body, was it called ball? As my Xcode's put in func, which is an annoying glitch, but there you go. Did the contact's first body, so body A it's called, did its node, which is optional, so you've got to unwrap it, name equal ball? So for the contact that's passed in, did its first body, the node of that body, have a name ball? Now you need to use body then node because as you can see, there's a body, it's got a physics body. We get passed in this thing and you can go from this thing up to here. So we're going from contact, body A's node, is it named ball? Do stuff, else if contact.bodyB.node.name equals ball, then stuff. Now the reason for this, we're checking body A and body B. It's a very fine philosophical point, but if we have a ball in the game and I haven't got the game running, I'll run it now perhaps, and it drops and hits something, did the ball hit the slot or did the slot hit the ball? Now we would normally say, speaking in English, we'd say the ball hit the slot. But for SpriteKit, it just sees a collision. It just sees two things hitting each other. It isn't aware of which hit which. And it's particularly challenging, of course, if there are two objects moving and they hit together, which one hit the other one. So we don't know which one, is it body A or body B is the ball. But this narrows it down, because we can say, the ball hit something else. Therefore, body A here, body A is ball. And here, body B equals ball. Now we don't know what, in this situation, body B is, or in this one, what body A is. We don't really care, because our collision between ball method has a check saying, was it a good thing or was it a bad thing? Otherwise, do nothing. There is no else here for, do nothing. If a ball hits another ball, nothing happens. It's totally ignored. So if contact body A node name is ball, then we want to say collision between ball, contact.bodyA.node force unwrap, and object contact.bodyB.node force unwrap, like that. And then here, just flip it around between body B and body A, like that. So if you play this back, we should be starting to get somewhere. So it'll bounce off the bouncer and land in the good thing and disappear straight away. Same for the bad thing. Boing, 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 ping, gone. So balls cannot collide together. We don't care. It can bounce off bouncers. Again, we don't care. It's only if we hit the good or bad slots that we actually care what happens. So next up, let's make it a game, an actual game. This is not fun yet because players want to have some sort of challenge. They want to score points. So they feel that they achieved something, even if that something is just nudging up a number on a CPU somewhere. They want to achieve stuff. So to make a score show on the screen, we need to do two things. Firstly, make a score integer that tracks the value itself, 0, 1, 2, 3, a million if you're really good. And then a new node type. So you've seen SK Sprite node, which comes from SK node. There's also SK label node, which comes from SK node. And this works much like UI label. It's much simpler perhaps, but it's very, very powerful and easy to use. It's not as clever as UI label, but it's good enough for SpriteKit. It has a text property to modify what text it has, a font, a position, an alignment, and so on. Lots of things we care about from our point of view. So first things first, let's add the label up here. We'll say as a property, var score label is an SK label node with the implicitly unwrapped optional. Then for the score integer, we're going to make this have a property observer to adjust the score level as things happen. So we're going to say var score, it's an integer, equals 0. Then use did set and update score label. So we'll say score label.text equals quote score, and then string interpolation, the score integer, like that. So it updates the label whenever the score value changes. We're going to use a font called Chalk Duster. I think in the previous game we used marker felt, so I am clearly going to be attacked by font warriors. That's okay. Bring it on. In the did move to view method, we're going to go ahead and add our things. So just for the end, so after all the make bounces, we're going to create our label. So we'll say score label equals SK label node, and it wants to know what font to use. So I'll say font named Chalk Duster, like that. Fantastic. Then give it a default text. So score label.text equals score 0. Then align it. Now I want this thing to align to the right of the screen. So I'm going to say score label dot horizontal alignment mode equals dot right, and then position it pretty much on the right edge of the screen. So it means you're aligning it. The position now is measured from the right pretty much. So we can now say score label dot position equals the very far right of the screen, x 980, y 700, like that. So it's nice and high up on the right hand side of the screen, and then add that child to our scene. So we'll say add child score label, like that. Run that back. Boom, score 0. Doesn't do anything yet, of course, but that's easily changed because we have this wonderful property observer up here which modifies the label as the score value changes. And so in collision between ball, we can say if it was a good slot, we're going to add 1 to the score, which is plus score, add 1 to it. And then we'll do bad, we're going to use minus score. And that's it. Press run now. So dropping the ball in the bad one, -1, -2, -3, and so forth. And then the good ones, fantastic. Look at that. Fantastic. So now pretty much all it takes to get a number even higher than Gangnam Style's YouTube views is to sit here and tap and tap and tap at the top of a screen directly over a green slot, and you will get infinite points. Hardly actually challenging. So let's add the actual challenge of the game. We're going to add a label over here called the edit label. Let's do that now. So we'll go up here. There's our score and score label, and a new property called edit label, and it's also an SK label node. We're also going to add a Boolean property called editing mode. Bool, make it false by default, and give it a property observer called did set. like that. So when editing mode is changed, we want to change the editing label. So we'll say if editing mode equals true, then edit label dot text equals done. Else edit label dot text equals edit. Now, because this thing has to evaluate to be true to make this done, and this is a Boolean, you can just write if editing mode. It means the same thing. That means if editing mode is true. That's perfectly fine and extremely common. So we need to create this thing. We'll put it on the left-hand side this time. So underneath score label, say edit label equals sk label node, font named, chalk duster, love it. Then give it the default text of edit. Then position it at CG point x80, y700. So it matches up with the score. And then add that child to our scene, like that. Boom. So it's pretty much identical to creating the score label. And there it is, edit. But there is something new that we haven't done yet, which is the important bit. And that's detecting whether the user tapped on the edit done button or is trying to create a ball. If I tap here, I mean ball. If I tap here, I mean edit button. Right now it just creates balls. To make this work, we're going to ask SpriteKit to give us a list of all the nodes at the point that was tapped and check whether it contains our edit label. If it does, we'll run a new method called toggle edit mode. If it doesn't, we want to execute the previous ball creation code as it was before. So to do this, we want to find the let location line in touches began, which is here. There we are, let location. That thing there. We want to find out which object existed at that position. And that's done by saying let objects equals nodes at point location as brackets sk node. So it returns an array of any object unhelpfully. Oops, sk node, square bracket. Square bracket, please. There we go. We can then say, does that array contain our label node, the edit node? And we've used contains already with the anagrams game. So we can just say, if contains objects edit label, then all we're going to do is flip around editing mode. So we'll say editing mode equals not editing mode. So if it's false, make it true. If it was true, make it false. And then else all that previous code. So you can use command and right brace to indent stuff. Like that. Boom. So that will only now create balls if the user did not tap the editing button. Go ahead and press play now. And you'll see I can tap there and it goes edit done, edit done, edit done. Over here, balls. So it's actually working quite nicely. That wasn't too hard. We're going to make one more change here, which is the actual challenge of the game. And you'll start to see what this game is becoming like. It's becoming like Pachinko, the Japanese game, which is most commonly known as Peggle on iPad. So if we did not click on the edit label, then we want to check, are we in editing mode or not? So if editing mode, then do stuff, else create ball. So we're in play mode. So the create ball thing here, which is going to go here, what should we do? So the create something thing, create thing. This is where your create ball code goes. This is where the new code is going to go. And what we're going to do is we're going to create boxes in there. So if we are tapping the editing button, toggle editing mode. Otherwise, if we are in editing mode, create something, a box. Otherwise, just go ahead and create a ball like normal. So what we're going to do is I want you to import a file, which I should have given you, and I have it somewhere around. Let me try and dig out the actual file from my file system. I'm being a bit lazy, sorry. Project 11, there we go, helper.swift. That file there, you'll have that in your files folder, promise. And you want to copy that into your Xcode project by just dragging it in. Copy yes, create groups, and add targets to normal. And this contains some very, very simple functions that do some work for you to generate random numbers and to generate random colors. It doesn't matter how they work, it really doesn't. We're just going to use them. You can have a look later on, and we actually go back and look at it in more detail much later on. But for now, we're just going to use them because it's much easier than try and pull it apart. It's not very long, but it's not easy to explain at this point in your Swift career. Really, it doesn't matter. Let's go ahead and use them. What we're going to do is we're going to place boxes when users tap on the screen. Now, what we're going to do is we're going to use rotation to make the boxes have different angles. So if you can imagine Z position, which affects the order of things, where high number means things are closer to us, therefore higher up in the game and more visible, and lower numbers mean they're in the background more. Z rotation spins them around. So you can make Z position with where they appear in the stack, and Z rotation, how much spin they have on the screen. We're going to use that along with random sizes. So the boxes are random rotations and random colors and random sizes to make our boxes be quite random in edit mode, but just a bit of fun. So let's size equals CG size, and width we're going to say random int min 16 max 128, then height 16. Then let box equals sk sprite node color random color, like that, and size should be size, our little constant we just made. Then box.z rotation, not position, rotation, equals random CG float min 0 max 3. And finally, box.position equals location. So to recap, create a size, create a sprite node with a random color at that size, give it a random rotation, position it where we tapped. We can go ahead and then add that to our scene by saying add child box. What you really want to do though, and the way the actual challenge of the game comes in, is to give it a physics body to make things bounce off it. So we're going to say box.physicsBody equals sk physics body, rectangle of size, box.size, then box.physicsBody unwrap.dynamic equals false. Don't move these things when they're added. So now press play and you'll see the game really starting to come together. I'm going to click and drop balls. Score. Fail. Then go to edit mode. And now when I tap, we get random things in the way. So it takes much more skill to get the balls landing in the right positions. So now I've got a nice little layout. Who knows where my ball will end up? Let's find out. I'll press done and drop a ball here. Bounce off 1, 2, 3. Rats. This one. Okay. Of course, you can create your own level however you want it to, but the game's really coming together now. It becomes much more challenging to score points. Of course, you can still cheat. I can just tap here to create balls down there because we create the balls where the location of the tap was. But you can fix that. That's for you to do. I'll leave that for you to do because that's not hard to do. You've seen the code here. This is where we create the location. Can you choose a different CG point to make it harder so it always uses the X position but fixes the Y to the top of the screen? That's down to you for some homework. Good. I like homework. We're not finished yet though, because our current destroy ball method looks quite tedious. Watch this. Wow, amazing. Gone. Boring. People want to see special effects. And we made this destroy ball thing a method for a reason. We didn't just put ball remove parent in here, even though that would have been fine too. We made it a method because we're using it in 2 places and we want to add a special effect here to do something cool. And remarkably, SpriteKit actually includes special effects as standard. It has a built-in particle editor in Xcode to let you make things like fire and snow and rain and smoke almost entirely through a graphical editor. It really is awesome. Now I've made an example particle effect for you and you'll be able to customize it to your heart's content as soon as this video finishes. So let's take a look at the code first. So in destroy ball here, we first need to find the path to our particle system file that we made already, that I made already for you. So we'll say if let my particle path equals nsBundle.mainBundle.pathResource, you've seen this before, and my particles are called fire particles. Type is SKS, which is the SpriteKit way of saving data about itself to a file. So if, oops, I'm going to brace there, if we've found the path to the fire particles, which of course we will do because we made it ourselves, then let's do let fire particles equals, now this is new, the new class called NSKeyedUnarchiver, and it loads complex data from a file. We will use it slightly more later on. I think in fact the very next project, if I remember correctly. So this thing extracts the fire particles from disk and makes them into actual particles on the screen. It's very, very cool. We say NSKeyedUnarchiver dot unarchive object with file, then pass in my particle path. I'm going to typecast it as SK emitter node. That's a new kind of node. You've seen SK sprite node, SK label node, and now SK emitter node. We then position that wherever the ball was. So we're going to say fireparticles.position equals ball.position, and then add that to the scene. Add child fire particles. Oops. At the end, ball removed from parent as before. So the first line, this is old. You've seen path for resource before. This is new. It just extracts that file from disk and turns it into an SK emitter node. It's very cool. It's not just SK emitter mode that can do this, by the way. As you'll see in the next project, you can save lots of things using NSKeyedUnarchiver and Unarchiver. It typecast SK emitter nodes. We can start using it. We add it to the scene, and that's it. Now, if you press run, get ready for some action because deleting balls is now much more fun. Bang. Fiery particles. Fantastic. You make lots of them. Boom. Look at that. It's on fire. Fantastic. This is all done through the particle editor, which is built into Xcode. I'll give you a quick whirlwind tour, and then you can stop the video and play and play and play. So open up on the left here, Fire Particles SKS, and that's what our particles look like. I do suggest while you're working with the particle editor, you go to this option here and change maximum to 0 so you can see what it's doing. That's the effect we have. I had 200, so it calculates 200 at a time. You get a puff and it goes away, which is why it sort of goes away. Yeah, it puffs, it goes away. And you can change all these options here. You know, how long should particles live for its lifetime, and how much variance should lifetime have? Should it vary the position? You know, should it move up much wider left and right or not, like that? So you get a much wider distribution or a much wider height distribution as well. It's down to you. It's your particles. Angle, which direction should they fire in? And I've chosen straight up, 90 degrees up. Speed, how fast should they move? And what range of speed should they have? Acceleration, do you want to apply gravity or wind? For example, I might say, you know, I want to blow in one direction. A bit more than that, perhaps. See them just floating to the right now a little bit. Whee! Fantastic. And this looks particularly good with, yeah, look at that. It's just like there's a little wind on there now. It looks particularly good with adding Y, because you get gravity effect. The things sort of fly away or come down again. So they're flying really fast upwards now. If I make that, say, minus 400, you see them drop down again. Like that. So it's almost like there's some gravity happening there now. Make that 0 again. So no wind, but just gravity. Look at that. Fantastic. Alpha, how transparent should be. You know, should they get bigger or small? Let's make these things bigger, perhaps. Get bigger over time, like that. Brilliant. Look at that. Should they spin round? Should we add much color or no color? It's down to you. So there are lots and lots of options you can spend time with playing here. I do suggest you look at the built-in Xcode template particles. You can go to a new file here, new file, and choose resource. Then choose SpriteKit particle system. Sorry, SpriteKit particle system even. And get examples so you can see spark or snow, rain, magic, fireflies. So magic, it looks fantastic. Let's have a look at magic. Yes, go ahead and create it there. Boom. Very simple effect made for you just using particles. And to make it work, there's no code. You just unpack the SKS file, add it to the scene, and you are done. So that is the particle editor, and that finishes our project. I know it's been a long one, but you have learned a lot, particularly because we went back to basics again with SpriteKit. So you've met SpriteKit now, you've met physics now, you've met some blend modes, you've met radians, you've met CG float, you met NSKeyed unarchiver briefly, but we'll go into more detail in the very next project. And you've got the firm foundations of an actually quality game now using SpriteKit. Things are so much more fun in SpriteKit because physics does so much work for you. For more information, see the website, hackingwithswift.com. You can buy this tutorial as a book for just $3. It contains stacks more detailed information to help you learn more, or you can buy the video in high resolution if you want to see exactly how things look. Alternatively, you can follow me on Twitter. I am @2straws. If I have the time and you've got a problem, follow me, get in touch. I'll do my very best to help you. Have fun.